So, you get your Raspberry Pi, and you notice there's these pins sticking out of it, and you think, that's just a super thing to do. But it's not, because you can plug loads of stuff into it, and Jim Darby's here to tell you what you can plug into it.
Right, just as we're clearing the decks, we're going to put that thing on properly, because this is very much literally hands-on. I'm going to need all my hands and stuff with it. It's basically tiny. Can people hear me okay? Is that working? Oh, it is fantastic. I'm going to do one of the things that you should never do in presentations, which is basically I haven't prepped anything beforehand, haven't cleared the decks, whatever. I'm going to actually take it out of the bag and talk about it as it comes out from the bag. Now, perhaps one of the most important things about the Pi, and here's one in yet another case, is that kids of all ages can sit there and start doing this sort of thing. Now, if you start doing this sort of thing to the family PC, take it apart, you take apart Dad's MacBook Air, there's likely to be harsh language involved. Worse, if you actually break it, it's likely to be even more harsh language involved. I think one of the key things I've said about the Pi is what I've just done. You can take it apart, do this sort of thing, and if you break it, well, you can get another one. You know, it's a bit ouch, but it's only, what, 20, 30 quid, depending on which version you buy and where you buy it from, and blah, blah, blah. It makes, as Linus Torvald said, it makes failure affordable. Which just means you can play this. One of the key points is that it doesn't have to be locked away in its case and only allowed out on Sundays. I'm also not using any anti-static protection as well, which is technically very, very naughty. But not to worry. How do I turn this on again, Ryan?
HDMI 2.
What, for this
That
one?
one, yeah.
HDMI 2. HDMI 7, HDMI. Oh, there it is. HDMI 2. Really weird order. You see stuff?
Yes.
Yeah.
Hey! Right. I need a pointy thing of pointiness, actually. Oh, skew is fantastic. Okay. There's the lighter here, not sure what that's skew. Oh, there we go, skewy thing. Right. The lighting on this really doesn't work terribly well. The key thing we notice is you've got these connectors on the, there, you see that? The famous connectors on the end. Now, just on the raw Pi as it is there, actually, I'm going to use the very long pointer thing. Let's see how disastrous this gets. This is not going to end well, is it? I've really got to do lower risk presentations. This is one of the key problems. See those two connectors right on the end there? Those two there. They're the easiest to short out, which is a bit of a pity, because they're the self-destruct. If you short those N2 connectors out, you're sorting the 5 volts, which is the main supply into the Pi, to the 3.3 volts, which is the power supply to the chip. That's your on processor there in the middle. And you will, as the saying goes, let the magic smoke out. All electronics works by magic smoke. If you let the magic smoke out, the electronics stops working. Now, if you want to connect stuff to the Pi, in theory you can actually connect straight onto there. But that's really, really risky, because just the slightest little whoops, and you've damaged the Pi. But even if you do, it's not that expensive. So, as a couple of our previous talkers have mentioned, there's a wide range of things to plug in. In fact, if you go out there, there is a wide range of things to plug in. So I'm going to start off. Actually, I'll take these apart. So I'm also going to grab the glasses and see what I'm doing. That'll probably help a bit. There we go. There's a very wide range of things to plug in. So I'm going to turn this bit out of here first. This is the Adafruit version of what I was just talking about. Right, there we go. Let's put that down there. Vague, see now? Right, that's got one end, the classic connector that goes on there. In fact, it goes on that way around. Come to that in a minute. which is why the previous comment about having to loop it over. And on the other end, it brings out all the connectors that are on there. But the colour balance and the focus is a bit rubbish and it's upside down. You can almost, but not quite, make out on that there, it actually clearly labels in, well, they're actually clearly readable, but it's pretty much gibberish unless you know what they're actually talking about. Every single contact is actually labelled with what's on that contact. Happy days. So you now know this is the 5 volts, this is the 3 volts, probably best not to short them. Right, okay. What I'm now going to do is this is a breadboard which loads up there. This is a relatively small one. I was going to take all the wires out, but we won't, so we'll just save a bit of time doing that. What we'll actually do is plug this into that. Whoops, we'll do it without disturbing this one. And get it all right. So what we're actually doing on this is I've got some circuitry that I'll come to in a minute, some very, very basic stuff on there. You can actually plug things in, so you can almost make out from that you can't quite read it, but I'll use the, actually use a bigger pointy thinks it works better if more dangerously, which is about half as good to me. So, one thing, when you're doing this sort of stuff, there is a vague colour convention you use, which you can almost make out on this. You can nearly read the letters GND there, which is ground, which means 0 volts. 0 volts, I only ever use a black wire for. That goes through an LED you can't see, which is a vague glass-like thing there, and a resistor going up to one of the outputs there. So that's me plugging in a resistor to the output. Now, one of the problems with this is the connectors on the GPIO talk directly to the ARM processor in there. There's no buffering, no protection. I've heard earlier, quite a few people talked about protection on stuff. There is no protection on that output, that's why it's so easy to blow up. Now I think, and someone's bound to correct me on this, the maximum output current on the GPIO is 16? 16 or 60?
16 for each port and 60 something total.
That's what I thought. You get quite a few people sit there and say, yes, well I managed to power my arc welder from one of the GPIOs. You can pull more current out than the 16 milliamps. You can, you shouldn't, because it will start to overheat parts of the chip. It's just enough power to power an LED. Now also one of the issues with this is you'll find that the ribbon cables have got, very typically, one side has got a little mark on it, could be a red stripe, could be white like this, and there's one part that's got a clear mark on it. That's pin 1, in quotes, or the cable to pin 1. Inconveniently, the Pi has pin 1 and it's orientated now top left. So you've actually got to plug it in like that. Which is, oops. Actually, that's an interesting point. I almost plugged that in wrong. You've got to be very careful on this and gentle. And plug the little adapter thing in. Actually, what I'll do is I'll hold this up. Not so good on the overhead projector, I'm afraid, but at least I can actually plug it in properly. That's what Syntac meant when you had to twist the cables around a bit. It's a bit awkward. So now, following my theme of extreme danger during presentations, I'm going, oh, there's a mouse and keyboard here. Excellent. Do they go anywhere useful? No, damn it. I could do with a mouse and keyboard if someone can. Fantastic. Before, okay.
Reset.
Again, we're on extreme danger here.
Give you a USB mouse if you want.
Oh, excellent. Oh, this is really cool. Just the job. You switch it on after you powered it up or not?
Yeah.
Okay. Let's plug all this in. HDMI is, that looks like an HDMI port, doesn't it? I so hope this works. The previous one we actually practiced this beforehand, but I didn't get around to it today, which is almost certainly a really grim mistake. Again, this is all absolutely classic. Yes, the SD card, always useful. Pop, 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 pop. That's looking good. Live demos, it's all exciting, isn't it? When it works. If mine will. Don't, let's not turn play here. Oh, it looks like it's booting. It was HDMI 4, wasn't it?
Yes.
I've got the glasses up now so I can read this. HDMI 6, HDMI 2, HDMI 4, that's promising. Work, please work. Don't ignore me. Beige in my phone, not seeing any output. That is really quite irritating.
He needs to reboot the pipe.
Reboot the pipe?
Yeah, you need to have had the
Yes,
HDMI cable in.
to the active.
Oh, it's got confused. That's slightly irritating. It's a good way to reboot it now. Access to the damn it.
It's a cable now.
Power off.
Let's power it off and let's power cycle it.
3 pins screw.
Oh,
There we go.
so that's now booting up. Blah, 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 blah. So I thought, what we've got on this, so I thought we'd start with some really basic stuff. Now, I mentioned earlier that we had an LED on there. So for those of you who were at the last jam, I did turning an LED on and off on an Arduino that I programmed from a Pi. Well, today we're going to be doing turning an LED on and off, but I thought I'd do it from scratch. As in the programming language, not from.
Get out your soldier now.
Yes, today's lecture will be semiconductor physics. Now, we're not going to risk everything. Where's the left mouse button?
It should be next to the trackpad. It's a little button.
It's a bit done.
Right now.
Oh, fantastic. Work. Oh, it's looking good. This works will be fantastic. Right. Remote sensor connections established. It's good. This is a scratch with the. Way, it's looking good. Whoops. This is scratch with the extensions to handle GPIO installed. Ooh, one called Blink. Let's give that a go. There's 2 Blink programs. I've got horrible suspicion. I can't remember which one's which. Let's find out. Let's see if this one does anything. Oh right, there's a quick diversion here. There's all these wonderful pins. Now, the naming convention in Scratch is of course utterly incompatible with the naming convention used on the circuit diagrams and everything else. So what they call pin 16 is known as GPIO 23 to everyone else. It's just magic, sorry guys. So, going through this, these are pointy thing again. Excellent. That's exactly what it says. When the go flag is clicked, forever, broadcast returns a message, turn pin 16 on, we'll wait a second, turn pin 16 off, we'll wait a second. Fantastic, flashing lights. What could be simpler? Let's see if it works actually. So we click the go. I quite like Scratch. It's deliciously simple. It's so neat. Yes! Epic win. Right, there will now be a appalling smugness as I switch to HDMI 2. Because. Hey! Flash it. That was massively silly example. I deliberately did that because This is a really, really simple example done using a few pounds worth of hardware, stuff plugged in. The only real danger with that is, as I mentioned before, getting any of these connections wrong. You have to be really, really careful. Excellent, we've now made lights flash. But there's more. Of course, you're hoping for more. You will have noticed I've installed a button. So we have a button we can press as well. Right, back to HDMI 4. Let's do some pressing of the buttons, what could be better. Let's find... Actually, it's not a good thing I did, because there's a long transition. This famous Blink program is just the Arduino version of Hello World. It's there to sit there and say that, yeah, you've got the system installed properly, because no one really wants to blink. You can actually buy blinking LEDs, so why bother? The answer, of course, is because we can. Always a good reason. So we can now open. My personal one I tend to use an awful lot is, because you need, well, that actually is called a heartbeat on quite a few systems, which just means not dead yet, not dead yet. So this one turns it on, wait to 10th of a second, get that out of the way. Funky thing of doom. Strangled myself on the headset. Thought this was going to be the fake thing, not the headset. There we go. On, wait 10th of a second, off, wait 10th of a second, on, wait 10th of a second, off. Wait 0.8 of a second, which should of course be 0.7 of a second if you want the 1 second loop round the time, but whatever. That's a little like heartbeat pattern. So, go. Oh yes, you also notice we haven't got sound. I was so happy in getting this working with all the I/O. It actually goes whoop at the end. So back again. Yay! Heartbeat signal. Right. Fantastic. But this, the key point behind this is your real basic stuff. You've written a Scratch program. This is a primary school age programming language, and it's flashing LEDs on what, depending on what you want to do. That was the key point behind that. It is basically that simple. Setting it up is not as simple as it should be. The hardware is trying to get Scratch to GPIO and file permissions and blah blah blah. It's a bit of an But once you've got the system set up, as you can see, that is a fairly small little Scratch program and flashing lights. Okay, let's do some input. Why not? So some more Scratch. Excellent. If you haven't got sound, it makes a rather good whoop noise. For reference, people in the office don't tend to appreciate that sort of thing. But that's their problem. So what have we got? Oh, push button, that sounds useful. We'll do that a lot. This is actually a variant of the previous program. So here, what we want to do, I want to run through the program. Again, keep on, and I can't say this enough, this is done in Scratch. It's supposed to be really, really easy to make things happen. That was the point behind all of this. So this program comes in, classic when clicks, which means whoa, when you get the master go, forever looping, if pin 7, which of course is known to everyone else in the universe as GPIO blah, where blah happens to be 4, obviously. It reads GPIO 4. The stuff on the website to use which maps into what. So read the sensor value. If the sensor value equals 1, i.e. if the button's pressed, go whoop, because we just like going whoop. Do the heartbeat thing. If it's not pressed, move 5 steps, and if it's on the edge, bounce. That's referring to Scratchy the strangely upside down cat. So, again, those are pretty daft things. It's just me trying to get it to do something. So let's press go on this. Doink. The button isn't pressed, and the cat is marching to and fro. Well, that means I've got too much coffee. But I have to do this in two phases. I press the button, the cat stops, and although you can't see it, the light flashes. Release the button, the cat starts moving again. I'll switch screens. I only need two screens actually. Let's go back to there. Yeah. So that's without the button being pressed, you know, little heartbeat thing. Press the button, yay, and we're back. Fantastic. So that's pretty damn simple. Now, as previously discussed, that is all a bit unprotected. You know, so a lot of people have talked about boards, and just about everyone said, we put protection on them. Why do we put protection on? Because it goes bang on. And it is really easy to actually do that. Really easy. That was actually because I was a bit concerned about time, and I hadn't noted down which connections go where, so I'll be really careful. Because you get it out by just one or two. It's way too easy to make a mistake, and that is a problem. But again, it's not the complete end of the world. It's just a bit of a pain. Cat marches to and fro. Cat. Yay. Cat stops. Cat starts again. Wonderful. Right. So now I'm going to be a little bit safer. That was actually the dangerous part. So let's actually shut that machine down. Because we're going to go and be slightly less dangerous now, there are loads of I/O boards of Pi. And everyone says, which one should I get? I do not want me or my kids blowing the Pi up. That would be bad. On the other hand, you've got this big, massive advantage, which is that even if you do, it's only 20, 30, 35 quid. It's not the end of the world. You are not destroying Dad's map, which is a big, massive bonus. So we can do, as is all turned off. Well, it's turned off. Superb. Not like that. So we've decided that yes, we managed to get that, and that was reasonably good luck, and I managed to not destroy a Raspberry Pi in front of an audience. Let's switch to plan B. There's lots and lots of add-on cards. I've only got time to demonstrate one, so we'll go for the GPIO board. It's got a Pi face written down. This is the justly famous GPIO board. Now there's a lot of different prices, things they've got on them, blah, 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 blah. It's worth pointing out that this one has, lurking on it, in that corner, what's roughly an Arduino, which you're going to skip over. It's got stuff to control motors, stuff to control other output devices. It's got blah, 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 blah. It's got digital to analog and analog to digital. So it's actually got both. They're just all there. This is probably one of the most expensive ones, and it's probably the one with the most amount of stuff on it. It's also the one that's most portable in a very literal sense. Again, being careful not to misalign the pins on this, because that's exactly the 16% exploding dating. Key thing about this is these three chips here, that one, oops, and that one. Very hard to do. That one, and that one are basically your cannon fodder. They go in between the Pi and the rest of the world. So in fact, what we can do now, we put that in, so we'll turn it all back on again and let it boot on.
It's switched to HDMI.
I was just thinking that, yes. But now we've got the GPIO board in it, and we can run various degree pressure. Actually, I'm running a bit short of time. I could run exactly those same demos, showing how to plug through on the GPIO board, but I'm guessing people You know, we've all seen any of these flashing buttons press. I'll skip that bit. Actually, what I will do is I'll stop that one and just go on to the final one. Amazingly enough, most of what I've been talking about is available out there. This is, actually let's switch back onto the other one. The Gert board's pretty much your Meccano kit. It was quite deliberately designed to be able, you could plug this into this, plug into that, you have to do all these connections from here to here and here and here. Now, it's my niece's 12th birthday next month. I wanted to get her into this sort of thing, but not at that sort of level. So I decided to cheat, somewhat inevitably. I thought, what's a really simple, safe, cheap introduction? So I'll finish on this one. I need to try to reboot the plane now. I just realised it's slightly irrepressible. So I need to move it to a different bit of hardware. Oh, my nose! Oh, I'll bounce the power. I'm going to play dangerous. So what I'm now going to do is, you really shouldn't bounce power, you can corrupt file systems, it's a bad idea. I don't know why that wasn't working. Oh, that might be now. Yeah, it's still on the wrong one, isn't it? Let that boot up again. Yes, it's noticed it, right. Let's switch back over to the other end. Good. This is the one I wanted to get to be a bit simpler. This is all in. It's working. This is all in the one sealed case, so makes life a bit simpler. I put a pie glow in there, which I know that Pomerania out front with. This is 17 LEDs? 18. It's 18 LEDs, and you can control them from Python and other languages. So just to finish off, I'll demonstrate doing that. No, it's back. Work. No.
Okay.
Hey! Excellent. So. Somewhere in here. Which one was it? It was Pygo example. That looks good, doesn't it? Actually, we need to do this one. Look. Well, oh. Yeah, can't, yeah, it needs to in front of it. It still doesn't, right? Anyway, I'll skip over that. The whole point behind this is that I've done that hasn't worked. It was miraculous. We'll switch back to what it actually looks like. So I need to finish off before Mike kills me. Key thing behind this, variable from Scratch and Python, 18 LEDs. They really are quite bright. I'll skip over this because they've got demonstrations in that at the front. Key thing about this is it's all sealed in the box. You can flash your LEDs and there's nothing that can go wrong, hopefully. Right, oh, I should also mention that I've used the Gert board. If you look outside the front, there are a load, and one more soon, that's the Pi face, yet another interface board. They're all subtly different. I don't think they're actually competitors as such. They all just do slightly different things in slightly different ways. And that's great. You can have a browse around and there's a ridiculous selection out there. And choose the right one for you. Right, any questions on any of that?
How do you spell Gert in Gert?
Ah, it's,
so we can Google it.
ah, right. G-E-R-T. Yeah, G-E-R-T-B-O-L. Your best bet is to have a look out there. Genuinely, you've got a fantastic selection of add-on stuff out there, complete with manuals. You can have a really long and lively debate about which one's better for what, which one's got better documentation, how does it work, how do you drive the output motor on a girt board from scratch, how do you drive whatever. You know, there's a huge long list of stuff. And it's an interesting choice. I would say, go through and think, you know, what is it you want to do? What's got the best instructions? What can you understand? So we still need to do a fair bit of work on the documentation of some of this stuff. It took me a little bit of a while to get the scratch talking to flash that LED. And it shouldn't be that difficult. In fact, we actually needed to try to start playing with Super. I said, I don't know why that one wasn't working. Python could just work out the box. Yeah, you do. I don't know why it doesn't. Perhaps because I was bouncing the pound.
You're using it as a normal application instead of Python.
You reckon?
Yeah, that's it.
You've already applied for it.
Let's give it a go. If I get this actually works, is it still coming up? You reckon it's still in Python? Right, okay. So I tend to write all my stuff with the.
Have you got the modules up and running?
It should do. Got a lot of new programming languages coming out. There we go. Way! Excellent. You work right. And lo, behold the bright shining. Yes, actually, that sums it up. It is completely taking the camera out of the water. It really is quite bright. People go, oh, it's a bit bright. You don't have to turn it all the way up to 11. One of the things that's actually quite useful about this is that the LEDs, you can not only turn them on and off, but you can set the brightness as well, which is just fun. I mean, that's just the example that comes out of the box with it. I can do a little heartbeat thing on it or whatever. There's various other toys. I was trying to figure out the numbering, but I still think that's actually quite a cute little pattern. But that's a good test sequence, and you can play that controller from scratch. So I haven't got that bit with it. Right, anyway, I'm going to go like looking at the end. Right.
I've got a question. You said it was for a 12-year-old niece.
Yes.
Have you shown it to her, and has she enjoyed it, and has she got hands on with it yet? And has it been successful?
Not yet. It's her birthday next month. This is actually quite an interesting point that Michael was going to kill me for overrunning, but she's programmed in Scratch at school, which I think is actually fairly rare, and her new school also does Scratch. She also saw some of the kit I had around over the summer and showed an interest in it. So I thought, like, right, I've got to give it a shot. To actually sit there and not provide, well, pretty much that, actually, with all that's on there, to actually not get rid of the girl's birthday, would I think be very poor. You know, my chart's giving my uncle to give him the thing and see what happens. It's worth a shot.
Yeah, have you tried it? Has she had a go?
Oh no, so her 12th birthday is next month, so she's going to have a long weekend visit for me to set the whole thing up and stuff.
I think it's going to work really well.
I think so too. Final point before I get lynched is it's interesting to note that I live in Ipswich, she lives in Poole in Dorset. The Pi, its case, its power supply, its keyboard, its mouse, its wireless dongle, its Pi Glow, blah 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 blah, costs less than a train ticket to Poole. And that's what I like to leave on. Any questions? Go ahead.